So the next section and this beautiful chapter is dealing with certain problems we have when the refractive index of the it's a lens. Naturally it has the property of refracting. So we are looking at some problems related to the refractive index of the human eye lens. So refractive index of the human eye lens is altered, which means that it's not the normal condition. So what are all the conditions related to this particular situation? How can we remedify them? That's what we are looking at. And there are basically three conditions. The first is myopia. It's also called near-sightedness. Obviously, the other condition can be stated as the reverse of this particular condition, that is hypermetropia. If myopia is near-sightedness, this is obviously far-sightedness. And the third condition is what is called presbyopia. Okay, let's look at each condition, how is it caused, and what are the ways to rectify it. So starting with myopia. So myopia, obviously nearsightedness. This alternate wording itself explains what myopia is. That is, the person with myopia can't see distant objects. So that's a point, which means that he or she can see objects which are near. So what's the reason behind it? The reason is that we know that for normal islands, human islands, so the far point is at infinity. We know that. But in this case, in the case of myopic islands, the far point is not at infinity, it is lesser than infinity, which simply means that you can't see objects at infinity. So the far point is lesser than infinity. So that's what is happening when the refractive index changes as far as persons who are having a myopic eye lens is concerned. Now let's look at the physics behind it. So this condition means that the vision will be only up to, so for myopic eye lens, the vision will be something like up to a few meters. So let's look at the physics behind it. Now you have the eye lens. This portion is the retina, and this is a myopic eye. So this is the point. I call it O. Here's the object is here. So this is the new point at which the person can see, and originally it ought to be at O dash. So something like that. It means that for rays which is emerging from the new what is called far point, obviously the rays are getting converged and then image is getting formed at the retina. But if you look at the original far point, which is at infinity, that's at here, that's O dash. So let's look at that rays. So for rays coming from, suppose the object is at O dash, which should be the normal infinity. So for rays coming from there, what happens is that so you can see that what happens is that the focus is actually in front of the retina. So this is support. The focus is for objects which are at infinity. So that's the key. The key point here is that for objects at infinity, as far as a myopic eye is concerned, the focus is in front of the retina. So that is the problem. That is how the issue is being created. So instead of the focus being on the retina, it's in front of the retina. So how can we cure this condition? The only way out is to use, you can use a concave lens of suitable power to rectify it. So I'll be drawing it, maybe I'll be drawing it here to get a better picture. So suppose you are using a concave lens. What happens is that not only the images which are now clearly seen, that is the images which are lesser than at infinity, but also the objects which are lesser than at infinity, also the light rays which are emanating from the objects which are located at infinity, that is this light rays. They also so we are using a concave lens, not the point, so there will be a small divergence, that is it's actually the rays are a little diverged and hitting at positions which is a little on the top side of the lens, which basically means that the focal length or the focus will be shifted towards the retina. So that is what is happening. The focus is shifted towards the retina. So this means that not only the objects at infinity, as well as those objects which are already clear. So both this stuff can be seen. Both the objects, that is the object, the new place, that is O, and the original infinite point, object at original infinite point O dash. So both the objects at O and O dash can be seen if you are using a concave lens of a proper power. So that's how you rectify a myopic eye lens. Now one more point before we finish this particular section. So so this is the physics behind a myopic eye lens. So what are the causes? What are the biological causes? So let's look at the biological causes of how this condition is caused. So there are basically two reasons. One is excessive curvature of the eye lens, and the second reason is that, of course, what if the eyeball gets elongated? That is, suppose you have the eye is like this, the focus is formed here, and suppose the eye becomes something like, the length of the eye, and if you take a cut section, the length of the eye increases. So even though in this particular case, suppose this is something like x centimeters, this becomes x plus x dash centimeters, something like that. So it means that now, even though nothing has changed with the property of the lens, you can see that because the eye has something like elongated, the eyeball has elongated, the focus or the image formation will not be on the retina, it will be in front of the retina. So that's the second condition. That is the elongation of the eyeball. So that's about myopia, the cause of myopia, and how to rectify it. Thanks.